Well, let's look at this rational equation, which, you know, kind of looks like any other rational equation, at least initially. It's got a numerator and denominator. I know that sounds kind of basic, but as we've said a few times, it's the denominator that makes all this fun stuff happen. Okay, because the denominator, remember, is a bad base. So we got x plus 4 over x squared plus 2x minus 8. By the way, this is still topic 10.3. We're kind of messing around with, again, all these rational ideas. I didn't quite give you one like this on the mini check where the denominator could be factored. That's kind of one of those things where, as you guys keep taking math, if you see something like a trinomial that can be factored, you should do it. It's just kind of like good advice because, well, when something is in factored form, you know, you might be able to see a little differently. You might be able to notice something. And besides, it's much easier to figure out what makes the denominator equal 0 when it's in factored form. So again, I didn't quite give you one like this on the mini check, but let's kind of take the advice and do a little XX and you know, multiply to be -8, add to be 2. Okay, now those numbers should be able to pop in your head as +4 and -2. Okay, +4, -2, get the job done. So now that we have factored, we're on to kind of our list of behaviors. Are you thinking about what makes the denominator equal 0? Pretty easy to see that it's going to be a -4 and a +2, so we don't have to kind of really sweat that too much. We can just say those are the bad numbers. On to the horizontal asymptote. And I'm very impressed with how you guys have picked up on these concepts. You're starting to understand the rules for a horizontal asymptote. It's the degree. The degree is the highest exponent. Notice I'm going back to the original form, because that's easier to see. The degree is a 2 in the denominator. Obviously, it's a 1 in the numerator. So, survey says, that's kind of my way of saying the answer is. If you like Family Feud, survey says. Y equals 0. Ding! It's the only answer on the board. 100 people said y equals 0. Okay, so it's the only right answer. Is there a slant asymptote? No. I mean, maybe that we can say none, or maybe that's not even on the list. Y-intercept. Okay, as I've said many times, be careful. Are you actually doing this? I know you could type this into Desmos and see the y-intercept, but there's a day where we're not going to have Desmos. So plug a 0 into the equation. Now, do you want to plug a 0 into this form, or do you want to plug a 0 in over here? I don't know. They're both the same, but it's a little easier to plug 0 in over here if you just kind of cover up the x's. You get 4 over -8. 4 over -8 is, well, -1/2. Okay? No big deal. It's just, there's a y-intercept at -1/2. So you plug a 0 in for x. X-intercept. As we've said time again, x-intercept is when the equation is equal to 0. Well, the only way the equation can equal 0 is if the numerator is equal to 0. So I kind of just slide it up there. -4. The reason I say, is because it seems like -4 has already been accounted for. It seems like it's a vertical asymptote. And I'll even say nicely that that's even a little bit, maybe a little bit to be determined. Let's go to Desmos. I guess you have to decide if you want to get that tool out or if you kind of just want to watch me. I always think it's better to participate. say kind of, honestly, there should be something that sort of bugs you, like mathematically bugs you. You know, like, it doesn't seem like what we came up with. You know, if you're looking at this graph, and you're looking at our answers, something's not lining up. It has to do with, again, this sort of this, it has to do with this x equals -4. You know, is x equals 4, excuse me, -4, is it an x-intercept? Well, if I go over here to x equals -4, maybe if I zoom in a little bit, but it's not touching the x-axis. So that's kind of strange. It sort of rubs you the wrong. How about it, is it a vertical asymptote? You know, we've seen more than a few vertical asymptotes now. -4, okay, at this point you guys should say, yeah, that doesn't look like there's an asymptote there. So that's kind of what's going on at -4. Now maybe from the beginning you also noticed that x plus 4 seemed to show up in 2 places. That's also a so what's happening here? Well, what's happening is actually a little bit easier seen on the graphing calculator. Nothing wrong with Desmos. But let me roll out another tool here. Okay, some equation. Maybe you'll have a teacher, maybe you'll buy a graphing calculator, you know. It's not bad to look at a graph on here and also try to learn some things. Now, it kind of looks like the same thing, but there's something happening at -4. Okay, now, what I'm gonna do is I'm going to do a little zoom in. I'm gonna do a little zoom in, and that's not quite what I wanted. Hold on a second. I need to get over a little closer. All right, so this is kind of like close to -4. Now, the reason I'm using the graphing calculator is because it allows me to kind of like, it's called trace. Now, if I trace the screen, there's like this little spider that shows up. Okay, pretend that you're walking along the graph. Now, I'm getting closer to -4. Okay, -4 is kind of like a spot, so you might want to proceed with a little bit of caution. Okay, so I'm at -3.8, I'm at -3.88, I'm at -3.9. Are you ready? And you kind of like hold your neighbor's hand. We're going to go right to -4. Ready? I'm going right to -4. And what happens? Okay, well, there's no fireworks or anything. Sorry, it's not that fun. But what happens is, poof, you disappear. Because you fell in a hole. There's actually a hole in the graph. Okay, there's like an empty space. Mathematically, there's no value. Okay, now the reason I wanted you to kind of hold somebody's hand so you can like pull them back up, and we can kind of get out of the hole and continue on the other side. Okay? But right when you're at -4, right when you're at -4, there's actually no value. When you graph this, you literally will show a hole in the graph, an empty space, an open circle. By the way, the other stuff is still there. We want to make sure that we don't kind of forget about what else that we did. You know, y equals 0 was a horizontal asymptote. Hey, there's an y-intercept at 0, -1/2. And of course, there's another branch over here. So go ahead and get your graph finished. But let's come back to, let's talk about this hole in the graph. Because there's ways that we can know. There's ways that we can be sure. And it actually goes back to the beginning. It goes back to the factors. You see, as soon as you have what's called a common factor, we'll write this down in a second, but as soon as you have a common factor, the numerator and denominator, that means, and actually, did you have space? It actually should be the first one in our list. Forgive me that I didn't remind you or maybe tightly spaced, but can you squeeze this up here? Okay, because as soon as I see x plus 4, x plus 4, that means that the bad number, -4, now let's make sure that we get that. -4 is still a bad number. It's just a different type of behavior. And again, it becomes a hole in the graph. But that also means that it can't be anything else. And so technically, x equals -4 never would have made that list. And technically, x equals -4 would have not made that list. Okay? And probably next time we do it, we won't even write that down. By the way, there's no X-intercept. But there's this hole in the graph. Now, here's sort of one of those math mysteries. That hole is an empty space. It doesn't exist. But even though it doesn't exist, it still has an x and a y value. Or maybe I should say, what would have been its x and y value. Now, I think we know what the x value is. It's the bad number. But what if I wanted to determine that y value? What if I wanted to write it as a point? As you saw on my calculator, I can't trace to it. On Desmos, I can't drag to it. But what I can do, now watch, this is kind of the new idea today. What I can do is I can temporarily cross off the problem. I can temporarily produce this new equation, new fraction, really. And the cool thing about this fraction is that it doesn't have a problem. It doesn't have a problem at -4. What that means is that I can plug -4 safely into this fraction. Notice how I say safely, because I don't get a 0 in the denominator. I actually get a number. And it happens to be a fraction, -1/6. And as I said a few moments ago, it's like what would have been the y value. It's like what would have been the y value. Hole in the graph. I don't know, I like that graphic, so I'll show that to you. So, you probably want to add this as like another rational rule. Another rational rule. The rule is, if the numerator and denominator have a common factor. Now, again, this is a little mathy. It's a lot mathy. But if you have x minus a in the numerator and denominator, a common factor, that means your bad number, x equals a, again, it's going to make a hole. It's not a vertical asymptote. It's not an X-intercept. In fact, it'll never be. It will only be a hole. I tried to come up with a way to, if you would like to write down how to find it, that you can think about these two steps. If this is too much to write, or you can simplify it. But I did want to present this text so you could have it if you want it. You can find the exact x and y value. You can find the exact point. Well, really finding the exact whole, but it's going to involve crossing out, getting that temporary fraction, and then once you get that temporary fraction, you are safe to plug in. And when you plug in, you're actually getting the y value. So that'll be kind of our new idea for today. Obviously, when you're ready, let's kind of try again. Let's see if we can fully analyze. I will share nicely that we're kind of reaching the end now. This isn't going to go on forever. So you've actually seen it all. You've actually seen it all. Now we just want to try to do it all. And I hope that we're getting closer and closer to a spot of that understanding. Now, this equation is going to have more than a couple things going on. Let's take our time with it. X minus 3, x squared plus 3x minus 18. And then, oh, look at this little surprise. There's this plus 2 at the end. And now, we really didn't talk about that yesterday, but if you remember from a couple days ago that plus 2 is a shift. So let's kind of see how that works into this. You don't have to throw out everything we've learned just because there's a plus 2. It's just going to end up being a shift. Now, before I do that, I was starting to write down the list of stuff. I guess it's no big deal. I can certainly write down this list of stuff here. A whole, maybe a vertical asymptote, probably a horizontal asymptote. Okay, there's different scenarios, and then X and Y intercepts. This is kind of like your complete list. What I was going to say though was before I start doing this, once again, take that sort of that good advice and factor. Okay, it's always a good idea to factor when you have a trinomial. Okay, now I'm only going to give you guys ones that are reasonable. It's not going to take all day to factor it. Multiply would be negative 18. Add would be 3 plus you put. So hopefully we can arrive at x plus 6x minus 3. That will be necessary if we're going to analyze this problem. Notice that the plus 2, that's important. The plus 2 did not disappear. It's still part of this overall equation. But we clearly have a numerator and denominator which is where most of the action occurs. And now that we've talked about it, that should be the first thing that you notice. Again, you should always notice the whole first, because it sort of overrules other ideas. In other words, the bad number. Now, it's important to still understand that 3 is a bad number, but that bad number is going to become a whole in the graph, which, by the way, is still another place that I can't touch. I technically can't touch a hole because I'll vanish. Okay, are you ready to do the sort of the temporary fraction? This is an idea that I want you guys to be able to do without Desmos. You should be able to produce the temporary fraction 1 over x plus 6. As I've said a couple times, don't forget about the plus 2. It's part of the equation. But here's the cool thing. I can take the bad number, and this is the part that kids will often ask about. What number do I use? Well, I always use the place where the hole is. So I take that bad number 3, but it's not so bad right now because I can plug in 3 and not get a 0 in the denominator. Okay, actually I get 1 over 9 plus 2. 1 over 9 plus 2. Now you can do 2 things with this. You can write that as 2 and 1/9. That's fine, it's called a mixed number. Or maybe a little bit better, I could change it into an improper fraction. Remember how you do that? You basically end up with a common denominator, or you can multiply the circle and you can add the arrow. You basically get 19 over 9. Look, you can make a common denominator. You're still gonna get 18 plus 1, which is 19 over 9. And that's my y value. Technically, that's the complete answer, 3 common 19/9. Do you guys wanna ask anything? Is there something you can say again? Okay. Hey, the other ideas haven't changed. You know, there's still a bad number. It's -6. It gives you a 0 in the denominator. It's gonna be a good old vertical asymptote. There's still a horizontal asymptote. Horizontal, I feel like we kind of talked about this a little bit. The horizontal asymptote has to do with the degree. Survey says y equals 0. Just being a little funny with the Family Feud. That's a, uh-oh, wait a minute. Whoa, y equals 0. Plus 2. 0 plus 2. Ding! And we're still alive. I'm glad you said that though. I'm glad you said 0, because it is 0 plus 2. We didn't talk about that too much, but basically it's a shift. Okay. Rolling along here. Y-intercept. Y-intercepts. Oh, yeah. Plug a 0 in for x. Now you see me do this a lot. I'm starting to kind of cheat a little bit. If you plug a 0 in for x, you just basically get -3 over -18. -3 over -18, that's positive 1/6 plus 2. Okay? See, you gotta take the whole thing. And so I gotta take the plus 2 as part of this calculation. So yeah, you get 1/6 plus 2. Now again, you can write that as 2 and 1/6. I'll be honest with you, if you're gonna keep taking math, you should spend a few seconds writing that as a improper fraction. 1/6 plus 2 is the same as 1/6 plus 12/6, which is 13/6. 0 to 13/6 would be super duper, if you're writing it as a point. Now, the X-Intercepts, sometimes we kind of have like good news. And the good news is that if you're gonna try to solve this equation equal to 0, that's honestly a little bit beyond the scope of what we need to do in here. If I'm gonna set this whole thing equal to 0, this plus 2 is gonna kind of wreak havoc on this. So there are times where we just say, you may skip that. That doesn't mean that there's no X-intercept. It just means that we're not gonna require you to find it without Desmos. Speaking of, what does Desmos say about this rec? Well, I hope it says all of these things. I hope it says that we have a O and an asymptote and the other goodies. Of course, don't forget the plus 2. I know this is what some of you are doing. It's not wrong. In other words, you're going to Desmos next. I probably should have modeled that it would have been ideal if we still marked our graph. But you know, whether you go there or you mark up your graph, you need to make sure that everything is shown. I do want to comment that the hole in the graph can be marked, but you have to keep in mind the value of it, this one is at 19/9. 19/9 is a little bit greater than 2. So again, what I'm kind of showing here is we expect to see a hole in this position. In fact, even the intercept, even this intercept of 13/6 is also in a certain position. We could expect it to be about right there. And of course, if we're looking at Desmos, we can kind of see that that is what's happening as the graph comes down and interacts with the intercept, the hole. Obviously, it approaches the asymptote. And even over here, we have a success. Don't forget about the branch over here. By the way, there is an X-intercept, but as I said, kind of like I said, we're going to skip finding it. So I don't really expect you to label it. It's probably just some random decimal. I'm looking at my notebook here, and it's kind of like that one more example that we actually have time to get to today. Instead of me saying, here's a video that maybe a few people watch, I'm going to use this time to expose you guys to this last example. It sometimes can initially look a little bit challenging. I'm certainly not saying it's easy, but there's a reason it's written this way. What I hope is that we can come to the realization that it's written this way to actually help us get our answers. So notice the way I'm writing out the numerator denominator, it's already factored. But again, that can kind of throw people off or maybe get you a little bit overwhelmed. Honestly, this would kind of be like the super problem. It's what we've been trying to build towards. Let's see if we can crank this out here. A lot of the answers are just by looking at it. You know, we are getting to a point where there's not like a ton of work that you have to do. I can mark stuff up, or we can just kind of look at it. X minus 1, X minus 1. I'll be honest, that's usually the first thing that you see. And what are you going to do with that? I hope you're going to label the bad number. Now, the bad number is still 1, but I hope you're going to label that as a whole. Usually it makes sense to continue to think about the whole. In other words, to cross off the x minus 1. Again, I don't really want to mark this up too much, but if I cross it off, I get this. Okay, now remember, that temporary equation can successfully receive x equals 1. With open arms, I can plug in 1, and I don't need to worry about a 0 in the denominator. I do have to do some math. If I plug in 1, I get -1 over -2 squared. Now be careful, -2 squared is actually +4. But I get the y value. The y value is -1/4. Continuing, the vertical asymptotes have to do with the rest of the denominator. Now, x equals 3, yes, I think that's pretty clear. You've seen that type of thing. By the way, the square doesn't change that. It's still x equals 3. But this x is going to also give us a bad number. It's just the number 0. So I can produce those two vertical asymptotes. Horizontal asymptote. You guys have been doing better with it. This one I'm not going to say survey says, but I am going to help you understand that if you multiply this out, you would get x squared over, if you multiply this out, You have to realize that this would give you an x squared, this would give us an x cubed, this would give us an x to the fourth. Now you'll notice that I didn't actually multiply it out to be able to see that the top is less than the bottom. In other words, to be able to say y equals 0. And at that time, we'll just stay at y equals 0. Y-intercept. Y-intercept. Plug in a 0 for x. So now, again, some of this you can just do mentally. Plug in a 0, plug in a 0, plug in a 0. Okay. Again, that spot right there. That spot right there, because I end up with a 0 in the denominator, says something about my y-intercept. It says that there isn't going to be one. If you would like, you can plug in zeros the rest of these places, but what I'm trying to show you is that it's not necessary. That's going to give you a 0 in the denominator. Maybe you're hoping I'll say skip, but the x-intercept is when the numerator is equal to 0. Now, be careful, just a little caution here. X equals 2. Okay, x equals 1. Not okay. X equals 1 has already been sort of classified as a whole. But nothing wrong with that number. Okay? It actually is the x-intercept. It's a good problem. And my way of saying, got a lot of math. Love to see you be able to be successful with it. Before we just go to Desmos. Now I know we are getting a little shorter on time here. I do want you to see that this guy is quite robust. There are asymptotes, intercepts, and even a hole in the graph. Oh my. Okay, there's a lot kind of squeezed in here. You see how I was able to put the hole in the right position? It's at 1, negative 1/4. So it's positive, negative. I hope you don't pack up yet. Just still have a moment that we can see what this looks like. I think we're going to see some good stuff, what we expect here. Type this correctly. I'll say that what you're seeing over here probably isn't like a big surprise, and what you're seeing over here is not a big surprise. It's getting closer to the asymptotes as it's always done. The branch in the middle is a little bit of the wild card. Okay, first of all, the branch in the middle does have to pass through this intercept, but by doing that, it crosses the horizontal asymptote. You've heard me say you can cross a horizontal asymptote. They only apply to infinity. So there's nothing wrong right here. And plus, we get a little curve so that we can pass this hole and then continue on our way to the intercept or continue up to this, excuse me, I said intercept, I mean asymptote. The branch in the middle is a little bit of a wild card. Okay, kind of expect different things every time you graph one of these. Homework helper. Keep up the good work. You guys